Hi, so I'm Aiden Romero, and in this video, I will be tackling about three reservoir problem. So in three reservoir problem, we have two cases, the case number 1 and case number 2. So for case number 1, we have the head loss of pipe 1 is less than the head at the reservoir B. So we have the reservoir A, B, and C. The flow of water from reservoir A is going to be divided towards B and C. If that happens, if the flow in pipe number 2 is towards the reservoir B, the piezometer reading will be higher than the elevation of the reservoir B. That's why the head loss in pipe 1 will be less than the head in reservoir B. And we can derive these equations from this setup. Q1 is equals to Q2 plus Q3. Head in the reservoir B is equals to head loss of pipe 1 plus head loss of pipe 2. Head at the reservoir C is equals to head loss in pipe 1 plus head loss in pipe 3. Now for case number 2, that means head loss in pipe 1 is greater than the head in reservoir B because the flow due to the flow being from the highest reservoir A and from the flow on B towards the junction. So we know that when we are dealing with the movement of water, the movement is from the region of high pressure to the region of lower pressure. Since the piezometer reading is lower, that means the movement of water will be from B up to the junction. From this, we can derive the formula Q1 plus Q2 is equal to Q3. Head at the reservoir B is equals to head loss in pipe 1 minus head loss in pipe 2. Head at the reservoir C is equals to head loss in pipe 1 plus head loss in pipe 3. So now, let's proceed to the examples. Sample problem 1. Three reservoirs A, B, and C are connected respectively with pipes 1, 2, and 3 joining at a common junction P whose elevation is 366 meters. Reservoir A is at elevation 933 meters and reservoir B is at elevation 844 meters. The properties of each pipe are shown in the table. So a pressure gauge at junction P reads 4,950 kPa. What is the flow in pipe 3 in cubic meters per second and the elevation of reservoir C? So to get the discharge 3, we will first get the discharge in pipe 1 and discharge in pipe 2. So since HF1 is given, which is 62.4, using the Darcy-Weisbach formula, HF is equal to 0.0826 times FLQ squared over D5. Substitute. HF1 is equal to 62.4 times 0.0826 times the coefficient 0.02 times the length 1500 times the Q1 squared all over diameter 0.6 raised to 5. So Q1 is equals to 1.399 cubic meters per second. So for discharge 2, HF2 is equals to 26.6. So substitute 26.6 is equals to 0.0826 times the coefficient 0.025 times the length 1000 times Q sub 2 squared all over diameter 0.45 raised to 5. So Q squared is equal to 0.488 cubic meters per second. So since Q1 is equal to Q2 plus Q3, Q3 is equal to 1.399 minus 0.488. So Q3 is equals to 0.911 cubic meters per second. So now, to get the elevation of reservoir C, using the same formula, which is the Darcy-Weisbach formula, HF is equals to 0.0826 times the coefficient 0.018 times the length of pipe 3, which is 900, times the discharge of pipe 3, which is 0.911 squared, all over the diameter 0.5 raised to 5. So HF3 is equals to 35.54 meters. So since elevation C is equals to 870.6, which is given, minus HF3, which is 35.54 meters. So elevation C is equals to 835.06 meters. Sample problem 2. Two reservoirs A and B feed a third reservoir C as shown. Assuming constant reservoir water levels given, compute the following with the use of the data given in the table below. Determine A. Flow rate at pipe 2, B. Flow rate at pipe 1, C. Flow rate at pipe 3. So, using the Manning's formula, HF is equals to 10.29 N squared L Q squared over D raised to 16 over 3. Transpose so that we will get Q is equals to square root of HF times the diameter raised to 16 over 3 all over 10.29 N squared times L, so that we can get the discharge easily. So this is a case 2 reservoir problem. So Q1 plus Q2 is equals to Q3. Head at reservoir B is equals to HF1 minus HF2 is equals to 10. Head at reservoir C is equals to HF1 plus HF3 is equals to 20. And HF2 plus HF3 is equals to 10. So, HF2 will be equals to HF1 minus 10 and HF3 will be equal to 20 minus HF1. So, at 1, Q1 plus Q2 is equals to Q3. So, substitute HF1 times 0.4 raised to 16 over 3 all over the length 1,800 plus square root of value of HF2, which is HF1 minus 10 times 0.5 raised to 16 over 3 all over 2,000 is equals to square root of the value of HF3, which is 20 minus HF1 times 0.8 raised to 16 over 3 all over 4,000. So HF1 is equals to 16.2 meters. So HF2 is equals to HF1 minus 10. Substitute, so 16.2 minus 10, HF2 will be equals to 6.2 meters. Then HF3 is equals to 20 minus HF1, which is 16.2. HF3 will be equals to 3.8 meters. So now to get the discharge in pipe 2, we will be using the same formula, which is the Manning formula. So substitute, HF2 is equals to 6.2 equals to 10.29 times the coefficient 0.011 squared times the length 2,000 times the unknown all over 0.5 raised to 16 over 3. So Q2 is equals to 0.249 cubic meters per second. So for the discharge in pipe 1, using the same formula, then substitute HF1 is equals to 16.2 equals to 10.29 times 0.11 squared times 1,800 times the unknown all over the diameter 0.4 raised to 16 over 3. So Q1 is equals to 0.234 cubic meters per second. So last one is the discharge in pipe 3. Using the same formula, HF3 is equals to 3.8 equals to 10.29 times the coefficient times the length times the unknown all over the diameter. So Q3 is equals to 0.482 cubic meters per second. So the last problem, which is the sample problem number 3. In the figure shown, value F is partly closed, creating a lost head of 1.093 when the flow through the valve is 0.0283 cubic meters per second. Determine what is the head loss of pipeline 3. So using the Hazen-Williams formula, which is HF is equals to 10.67 L Q raised to 1.85 all over C raised to 1.85 times D raised to 4.87, we will get the unknown, which is the head loss in pipe 3. So using formula, substitute HF is equals to 10.67 times 300 times the discharge 0.0283 raised to 1.85 all over the coefficient 80 raised to 1.85 times 0.3 raised to 4.87. So HF is equals to 464 meters. So to get HF2, we will just simply add 1.093 plus 0.464. So HF2 is equals to 1.557 meters. So to get HF3, we will just simply subtract 1.557 from 6.10. So HF3 is equals to 4.54 meters. So that's all for my discussion about 3 reservoir problem. Thank you for watching.